standard deviation. But girls, I've got to say 95% of the time, you'll just be using your calculator, thankfully. But today we're going to have a quick look at how to do it by hand. Okay, so the thing about what is variance standard deviation, they measure how spread out the data is. Chloe, focus. Like, for instance, if the bigger the standard deviation or variance, the more spread out the data is. I can't say comparing it to this particular value. It'd be more like if you have two data sets and this one's standard deviation is bigger than this one's, that means this one is more spread out. Do you know what I mean? It's not so much that if it's bigger than one, it's this. If it's less than one, it's this. That's not how it works. Anyway, so at the moment, all we've done to consider spread is find the range and interquartile range. But the range only considers the highest and smallest value. It doesn't even consider all the values in between. And the interquartile range only uses the two quartiles. It doesn't even matter about the highest and biggest or any other value. So they're not the best way to measure spread. Does that make sense? Yeah. Girls, focus, please. So that's why standard deviation and variance are actually better, because they will take into account every single value. So it's considering everything, which is better. Okay. So, and that might be something you may end up using in your IA. So it's worth finding all those things if you care about how spread out it is. Now, consider, this is kind of the rule. I don't want you to stress about it. I'll explain it, but I don't stress. Consider a set of n data values, x1, x2, x3, x4, all the way up to xn. N could be 10, n could be 100, so there could be 100 data values, whatever. The mean we write as x with a line on top, or does anyone remember that other symbol for mean? It's a weird one. I was about to say that. It kind of looks like a U, but it's a Greek letter. I'm pretty sure it's mu. It looks like that. Anyway, but we're focusing on this. Does anyone know when the difference is between this and this? When to use what? Yes, Lisa?
The U is used for the whole
population. And this one's used for? Sample, beautiful. So obviously this one's using the sample mean, that's fine. Okay, so now, what does this even mean? First of all, I just want you to look at this and compare it to that. Girls, look up. If the standard deviation is S or Sn, the variance is Sn squared. Therefore, the variance is just the standard deviation squared. Let's write that down. Variance equals the standard deviation squared. I might put in brackets, put a squared. So now we know their relationship. Or you really, like if you know one, you can easily find the other. Very easily. Is everything okay? Cool. Now, what does this all mean? So, does anyone remember what this symbol means? Sum, good. So it's the sum from I equals 1 to n. In other words, when I is 1, that would be x1. When I is 2, x2. When I is 3, x3. All the way up to xn. Does that make sense? Sort of? So basically, I'll kind of write it out. Give me one sec. So far we know that this would be, let's say n is 5, if you don't mind, just to make it a bit easier for us. Everyone okay? You don't have to write this down. I just want to show you an example. So in other words, this is a sum. First, when I is 1, that becomes x1 minus the mean squared. When x is, and then plus the next one, because sigma here means sum. Everyone okay? Plus x2 minus the mean, all squared. So I'll move this around. Plus, what's next? Yep. You know what? I'm just going to make this 3 now. Just to make life a bit easier. Is that all right? I'm being lazy. I'm going to make it 3. And then what should I divide all of that by? According to this denominator. N or 3, yes. That's all that means. Anyway, it just looks scarier, the original formula, with the sum and everything. It looks scarier, but that's actually all it is. All the way up to whatever value of N is. Okay, now obviously for really high values of N, like 100, there's no way you'd do that. All of that work. You'd use the calculator without a doubt. But I guess technically it's possible. Anyway, I'll show you how to do it by hand, but it's pretty rare that you'd actually be asked to do that. The smaller the variance and standard deviation are, the closer the data values must be to the median, or often it sets the mean. For instance, girls, if you were to do a dot plot and your median is here, or mean, I'll put median, but often it's said mean. And let's say if for a really small standard deviation, the dots would be quite close to that mean. Does that make sense? But if you had, let's say the blue is something with a really big standard deviation, like it's just more spread out. Is everyone okay with that? Beautiful. We usually use the standard deviation rather than the variance. I don't really know why. It's just more commonly asked for. Standard deviation is a useful measure of spread for relatively symmetrical data rather than skewed data. Because, like, for instance, if all my data was up here, really skewed like that, the standard deviation doesn't really tell us about that. And that's why it's kind of better to be relatively symmetrical, because it's just talking about how spread out it is. Okay, ready? The number of students that missed the bus to school were counted each day during week 1 and 2 of term. So in other words, what does it even mean? So week 1, let's just focus on week 1. Can anyone interpret the data? What does 3 probably mean to you? 3 is probably the number of students that missed on Monday. 6 is probably the number of students that missed on Tuesday. Otherwise, it would just give one number. You know what I mean? So it's multiple data values. So they must have something to do with the days of the week. Is everyone okay? Okay. So now, find the average number of students per day for week 1 and 2 separately. In other words, we want to find the mean. Now, girls, we absolutely can use our calculator for that, but I'd like us to do it a bit more by hand, but, I mean, not using our GDC. Do you know what I mean? So, for A, every time. Week 1. How do I find the mean? So what do I put? What do I write down?
3 plus 6 plus 1 plus 4 plus 5 over 5.
Beautiful, because there's 5 of them. Is everyone okay? Beautiful. And does anyone mind? Well, I just look at that. It's 19 on the top, I believe. Tell me if I'm wrong. 19 divided by 5 is about 3.8. Beautiful, thank you. I think it's on the next page, but anyway. And of course you can use GDC, but... And then for over here, week 2, we do the same thing. 1 plus 4 plus 2 plus 3 plus 2, I think that's right, over 5. What do you get? 12? 12 over 5 is 2 points. Beautiful. So is everyone okay? Just from that much, what would you say? Well, might that be in week 1? What's happening in week 1? So not used to their new schedule, tired, not used to their getting up early, all that stuff. Maybe, or maybe not having all their things organised. Anyway, but these are sorts of things you might think about in an IA, isn't it? Okay, now B, I want to first show you how to use the calculator to find the standard deviation of each week. So I'm going to show you the GDC now. First, we're going to open a spreadsheet, enter this data for week 1 and week 2, and then we're going to use 2 variable statistics and look for the standard deviation, okay? Okay, now, if you were able to enter everything into your calculator and find all the stats, you would get 2 standard deviations in a way. You're going to get something like this, looks kind of like a sigma, and something with an S. Sample, population. Okay, now, to be honest, I use population more than this one on the top, more than anything else. But I understand that the formula used S. So, Actually, just tell me what the values are. So, who can tell me the values for week 1? S and the sigma. So, can you tell me the sigma first? From your calculator.
Is it like that with a y next to it?
No, okay, good question. Do you want the Y one or the X one for week 1? You should have put the week 1 as your X.
It's 1.72. Oh, that's
Yep, cool. What about the S for X?
1.9.
Cool. Okay. Now, for now we'll just leave it at that. Both are correct. Can anyone do the same for week 2, which should have been your Y? It's up to you if you put it in there though. Yes?
I just have a question. Why did you put an equal sign to the sigma one, and for the S one you put like an approximate?
Because it was a mistake. Yep. So, next sigma. Yep. S. 1.14. Okay, beautiful. All right. Now, girls, which one is more correct, to be honest? I do use population more than anything else. So let's just focus on this one. These. Now, girls, what do you get from that? From those 2 sigma values? Week 1 had a higher average, but it was also more spread out and away from the median. Whereas week 2, lower average and more consistent. That actually makes a lot of sense, and that is generally better. Like, for instance, if you want to do well at something, you want to do it more consistently. You don't want your marks to bounce back and forth, low, really high, blah, blah, blah. You kind of want to be consistent. Does that make sense? So it often is the case, especially in an IA, you're going to want results that have a good mean, and in context, like for instance in this context, a good mean is low. But we'd also generally like a smaller standard deviation to be more consistently. So I consistently get marks around 80, as opposed to I inconsistently get marks around 80. Do you know what I mean? For the solution, I've given you the averages. Given it to you. We've already found them, but they're the answers. Now, I want to use that and use tables to find the standard deviation. Okay? By setting it up in a table, we can actually do it a bit more by hand. And I will be interested to see if it's the sample one or the population one. Okay, you ready? So, what's happened here? What have we put in this first column? For week 1, all the actual results, or the actual number of lates. What's in this column for every single one of them? The mean for that week. Everyone okay? So now, what do you think I need to put in this column? What do I need to do? Yeah, so 3 minus 3.8. Is that okay? What is that? Negative 0.8. Okay, so that's negative, but that's okay, because you know what? Over here, I'm going to square it and everything will become positive again. So that's okay. What's 6 minus 3.8? Yes? What's 1 minus 3.8? What's 4 minus 3.8? Yes. What's 5 minus 3.8? Okay, beautiful. Now, girls, just to explain what I'm doing here, what we're doing here, is we're finding these in here, the individual ones. We're doing the subtraction. And now we'll square it, okay? Okay, so who can tell me what should go in this one right here? Yes, that's right, because 0.8 times 0.8 is 0.64, that's right. You can always do it in your calculator, just be careful to make sure you square the negative. Or technically you don't even need to include the negative. Anyway, 0.64. What's 2.2 squared? 4.84, thank you. Thank you. What is 2.8 squared? 7.84. Girls, is that right? Did I write the right thing? Girls, why aren't I bothering to say the negative? Why is it okay for me to do that? Technically it's wrong, but why is it okay? It's going to cancel anyway, so I don't really need to stress about it. What's 0.2 squared? 0.4, yes. Girls, does anyone remember why, 0.2 times 0.2 has 2 decimal places? I'm just curious. Do you remember? Using your year 7. Year 7. That's right. In the question, there are 2 decimal places. That means in the answer, there should be 2 decimal places. So you can do 2 times 2 is 4. Oh, but I need 2 decimal places. So I put the 4 in the last point and fill in that with a 0. That's how you do it, by the way. And that's actually useful for paper 1. Anyway, what's 1.2 squared? Now, girls, how could you have done that without a calculator? 12 by 12 is 144, right? And then, how do you know where to put the decimal point?
Because it would have had 2 behind.
2 decimal places again, because the 0.2 and the 0.2. Very good. These are things to think about just because you're doing a paper 1, non-calc. All right, so is everyone okay now? You may not know where I'm going. So girls, this last column is all the xi minus the mean squared. According to the formula, you flip back. What do I have to do with all these last values? Go back. We've already squared. Add them together and then what? N, which in this case is 5. Very good. So you're actually using the formula, but step by step it's actually not so bad. So, and I'm very curious to see what we get. So, I'm hesitant to put either S or sigma because I'm not sure which one we're going to get. But let's do one thing at a time. So, let's add all them. Can someone just add them, a total? And did you round it to 3 significant figures or was there another one? Beautiful, beautiful. Okay, now, so I need to take that 14.8 and add it up to, divide it by 5. Which is just under 3. Can anyone do that for me? Okay, now let's have a look. So what have I forgotten to do? Square root. I forgot. I was focusing so much. Apologize, girls. I was focusing so much on this one. I forgot that with the standard deviation, we actually have to square root. Does that make sense, girls? So now, everything's good. I'm just going to add in a square root. That's all I need to do. So I just forgot. Thank you. Now, wait a minute. That was the sigma one, wasn't it? And that's another lesson in that generally we use sigma unless the question either tells you to find S or tells you to find the sample standard deviation or uses the word sample in it. So now, girls, what I've done is I've been a bit tricky. I put some data in here, put the frequencies here. Now, first, fill out the rest of the table. Then, use whatever you have in the table to find the mean and the standard deviation. Does anyone need an explanation of any of those? Do you know what fx means? Yep. So here, it would be 1f times 4x, so just 4. Is everyone okay? I'll give you a moment to fill in the table and then have a go at finding the mean and standard deviation. If you're not sure, that's okay. We'll go over it. How do we find the mean? It's a whole different thing because there's frequencies. To find the mean, you could either just put the first 2 columns in a spreadsheet in your calculator, making sure the second column is for frequency. Or you can find the sum of the fx column and divide it by the sum of the frequency column, and which is 100 divided by 14, which is approximately 7.14. So then you fill in the mean column with 7.14. Then you find the differences between the mean and the original values of x and fill in the second last column. And then to fill in the last column, you square all of the differences and you should get a positive value for each difference. Then to find the standard deviation, we have to remember that each x value has a frequency. So for each of the differences, we have to multiply them by the frequency as shown in this formula.